All right, so let's take a look at this first one. We're reflecting it over the x-axis, right?
Yeah.
So, and this is a dialogue between me and you. It's not just me talking. I want to do this with you, not for you. All right? Okay? So, so is the x-axis vertical or horizontal?
The horizontal.
It's the horizontal. All right. So when we're reflecting over any line, and we always have to reflect over a line, we have to take a look at the distance each point is from that line of reflection. How far is this point right here from the line of reflection?
2. 1.
Right, and so it's going to remain 2 points or 2 spaces away from that line of reflection. So this point will now translate right here. How far away is this point from the line of reflection?
2 points.
2 points. Okay. How about this point?
3.
So it's going to be right here. Okay. How about this one right here?
3.
How about this one right here?
4.
How about this one right here?
Also 4.
Also 4. So then we can connect those dots. So we can safely say that there we go. And that's all you have to do for a reflection.
So it's like a mirror image of it?
That's exactly what a reflection is. It is a mirror image of the original object.
Okay.
All right. Would you like to do number 2 together? The rotation? Okay. So for our rotation, what we're going to do is I'm actually going to take a picture of this, right? Now, I'm taking a picture of it because I can't physically move this page quite as easily as you can. So the directions tell us to do a 90-degree clockwise turn around the origin. The origin is at 0, 0. So I want you to rotate your page 90 degrees clockwise. Just go ahead and rotate it 90 degrees clockwise. Have you done that?
Yeah.
Okay. So we know that our rotated image is going to look like this. But we need to place this exact drawing on the original grid. So what I like to do is typically I like to just go ahead and write down the coordinates that I'm using, that I see here. So what is this point right here? What is its location using the x and y grid points?
1, 4.
1, 4. Okay. What about this point right here?
2, 4.
How about this point right here?
2, 3.
And then I would continue on the rest of them. So that's 3, 3.
Yeah.
And so if you continue in this manner, you'll get a list of coordinates, right? And so then all you have to do, and let's go ahead and finish it. So then what's this point right here?
3, 2.
How about this point right here?
4, 1.
I think that this one might be 4, 2.
Oh, yeah, 4, 2.
This one right here is 4, 1. There's your 4, 1. This one is 2, 1. This one is 2, 2. Of course, they have a figure that has a lot of different corners or vertices, which makes it longer. All right, and then this last point is 1, 2. And then rotate your paper back the way that it normally sits and just plot the points. And so you end up with this shape. So 1, 4 is right here. You're excused. And voila, you have your new image. So is that helpful?
Yeah, it is. Thank you.
Okay. So why don't you tell me how to do number 3?
Okay. So, across the line, y equals -1.
Okay, so where is y equals -1?
Would it be like on the y, well, y -1, I guess?
Would it be horizontal or vertical? I think that's an easier question to ask.
Vertical.
Not exactly. A y equals -1 will be horizontal. Because along this line right here, every point on that line has a y value of -1.
Oh, okay.
So when you have x equals, that's when you have a vertical line.
Okay.
And if it's y equals, you have a horizontal line.
Okay, that makes sense.
All right, cool. All right, so what coordinate will this point now move to?
I think it would move to the point right under the line -1, or y equals -1.
All right. So it goes right here, right? So that's 2, -2, isn't it?
Yeah.
Okay. All right.
So then I would just make the triangle like the opposite, I guess.
Yeah. So where do the 2 base coordinates go?
0, 1, and
0,
4, 1.
Okay, because that's 2 over, or 2 above the line, and the original is 2 below line. Same deal here. All right, and so then, where's my little...
Okay.
So go back to this tool. Oh, come on. Of course, there you go. All right. And you were successful. Good job. Do you have questions on translating?
No.
Okay, I figured that one is probably a little more straightforward. Do you want to explain to me how to do this one?
Sure.
Okay.
So first I would move my paper 90 degrees counterclockwise.
Okay, so I'm going to take a picture here so I can do that. And counterclockwise, the opposite of the clock, okay.
Then I would write down the points.
Okay.
So the first point would be negative, negative 5, 4, I think. So negative 5 and then 4.
Negative 5, 4. I do not think we have a negative 5 here. Let me double check. So Counting from the origin, -5 is 1, 2, 3, 4. Oh, you're talking about this one right here. Okay, that's funny because I was thinking this point. No, you're right. Okay,
Oh,
that's my bad. -5, comma 4. All right.
and then for the point that you just said, it would be -4, 1.
Okay.
I think.
Yeah.
And then.
But wait a second. Remember, we want to be looking at the drawing from that we rotated around. So we're looking at this drawing right here, not the original.
Oh.
So I agree, this is -5, 4, but that's from the original diagram. We want to find the coordinates of the image by that in that rotation. So we're looking at these points here.
Okay. So, okay, I'm a little bit confused on this one.
Okay, that's fine.
I'm not quite sure where to start. What's the point?
Okay, well, we have 4 places we could start. How about right here?
Okay, so I think that point would be -1, 4.
Remember, it's x first, then y. So how far to the left of the origin did we go?
-4.
-4, comma.
1, I think.
But we
Yeah,
went down. We went down 1, so that's a negative. So it's,
Oh, okay. Yeah.
all right. So what are the coordinates of this point right here?
-4, -5.
So -4, comma -5. Totally agree with that one.
And then -1, -2.
-1, -2. Okay, so that's this point right here. I'm going to put a space there. So we have negative. You said -1, comma -2. Because we don't connect -4, comma -5 to -1, comma -2. So that's why I left the gap. So what about this one right here?
-4, or -1, -4.
And I'm going to type whatever you say. So yeah. Okay. So that looks pretty good. All right. So then let's go and plot those points on the grid. The original grid. So -4, comma 1 is right here. Then we have -4, comma 5. Then we have -1, comma 4. It's right there. -1, comma 2. And there you go.
Oh, okay.
And so that's the easiest way to do a rotation. And it sounds like you got the reflections down really well.
Yeah, I think I did the reflections pretty well.
All right, so let's do this one right here.
Okay.
All right, so this one says dilate from point -7, comma -7 using a factor of 2. All right, so the first thing we have to do is identify where is -7, comma -7. So where should I be looking?
In the negative, I don't know which quadrant that is, but it's like on the bottom left.
1, 2, 3, and 4.
So quadrant 3.
Quadrant 3. Okay, cool. So -7, comma 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And so, all right, perfect. So the easiest thing to do at this point is to take a ruler or a straight edge. And what I'm going to do is I'm just going to draw a straight line from my point of dilation through each one of the vertices of the triangle. And the advantage to doing this is that I know absolutely that the new points, the points of the image, will be along those lines. I know that's going to happen. So if I get points that are not on that line, I know I've done something wrong.
Okay. Yeah.
All right. So we have a dilation factor of 2. That means that the side lengths will be 2 times larger. And the area is going to be the scale factor squared times larger. So the area is going to be 4 times larger. And it's also going to move a little bit on the grid. So what I'm going to do is I'm going to make a nice little slope triangle. So from my point of dilation, how far up and how far over is this point right here?
It is 1 over and 5 up.
And I don't really care too much about direction, the positive or negative, because I know that it's going to be on this line somewhere. And so we're going to multiply both the rise and the run. I'm misusing rise and run, but please forgive me. We're going to multiply both of these numbers by the scale factor. So what used to be 5 points away from the point of dilation is now going to be twice that distance. So how far up will the new point be?
10.
10. So let's go up 10. So I've already gone up 5, 6, 7, 8, 9, 10, and it's going to be on this line. I know it's going to be on this line. And luckily, 1 times 2 is 2, and that's 2 over already. So I've found my new point for this original.
Oh, I understand where the factor of 2 comes in now. I didn't really know where that was before.
That's fine. Yeah, I'm happy to answer the question. There's nothing worse than struggling at home and not knowing what's being asked of you, right?
Yeah.
All right. So what about this one right here?
So it'd be 1 over and 2 up.
Okay, so you're doing this one. That's fine. We can do this one. 1 over
Oh,
and 2
yeah.
up. And so we're going to multiply both those by 2, and the new point is going to be?
2, 4, or 2
Yeah.
over 4 up.
Oh, look, and it's right on that line. All right, what about the last one?
So for the last one, it was 5 over and 2 up. So it would be the same, well, never mind.
So what will I do with the 5 and the 2?
So you'll go up 10 and over 4.
Over 10, up 4.
Oh, yeah.
And that takes us right here. Oh, that's right on the line.
So then would you just connect them?
Yep, and there you go. That's it.
Oh, that's a lot simpler than I thought it was.
Yeah, it's really not too bad. It's kind of fun. It looks like the triangle is exploding out of the point of dilation.
Yeah.
And that's all it is.
Okay.
Have I fully answered your question, or would you like to do some more?
I was a little bit confused on the one that was reflect over the line x2, then dilate from the point.
Okay, would you like to do that one together?
Yeah.
Okay, so this one has a reflection and a dilation, and it tells us to do the reflection first. So let's draw the line of reflection. Is it going to be a horizontal line or a vertical line?
Horizontal. Oh, wait, no, it would be a vertical.
Yeah, it's tricky, right? It's
Yeah.
so easy to see x and think horizontal. But x equals 2 is a vertical line along where x is equal to 2. Because all the points along this yellow line have an x value of 2. Now, incidentally, the equation y is equal to 2 is not a function because it fails the vertical line test. But that's not part of this problem at all. All right. So let's reflect this image.
So, was reflecting just the mirroring?
Yep. Just like reflection in the mirror, yes.
Okay. So, wait. I thought I understood this one, but now I'm not quite sure.
Well, I think you do understand. I really believe you do. It's just maybe a little unsure of it. So how far away from the line of reflection is that point that I just circled?
Oh, 5? No, 4.
4.
4.
So it's going to be 4 points on the other side of the line of reflection.
Oh, yes. Now I think I know.
I'm having troubles getting us to. Okay, that's close enough. All right. What will I do with this point?
You would do it, because that one is 2. 7.
7, okay.
And then this point would be 5.
I don't think this one's 7. I think this one might be. Oh, I think it is. I just think I put my point in the wrong place.
Oh.
Come on, you should have said, Mr. Framke, you totally messed up. And it would have been okay for you to have said that. Come on, there you go. Okay, so this is our reflection. And now we are going to have a dilation with the, we're going to have a dilation. And let's, just for funsies, let's find the point of dilation. And it says the point of dilation is -8, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And I'm afraid if I do a dilation factor of anything larger than 2, it's going to jump off the page. I'm a little nervous that I'm going to jump off the page anyways. So we'll go with a dilation factor of 2, okay?
Yeah.
All right. So I'm going to make my straight lines. Now, I'm not being as careful as I was on the other one, so I might be a little bit off, but that's okay. All right. So now what?
So then you would find the number of points away each one is from the center of dilation. So for the first one, I said it was 3 points over and 0 up.
Okay.
And then you would do that times 2 each one.
Okay.
So 3 times 2 is 6 and 0 times 2 is 0. So you would go over 6.
Perfect. What's
and
next?
Then for the point above it, I guess, it's 6 over and 1 up.
Okay.
So 6 times 2 is 12, and 1 times 2 is 2. So you would go over 12 and up 2.
Okay.
And then for the last point, you would go over 5 and up 3, which would be 10 over and 6 up.
Down.
So, oh yeah, down. And then I think you have your triangle.
There we go. And that's it.
Okay.
I feel pretty good that you understand this at this point.
Yeah, I do.